So the last section of this chapter is just adding and subtracting the radicals that we've been doing. And it's very similar to Algebra 1, where if we had x plus 2x, because our x's are the same, we would be allowed to add the coefficients. Well, the same thing happens here. We're looking for the same radicands. And remember, radicands are the numbers underneath the radical. So that would be 6 and 6. And since they match, we are allowed to add the coefficients. So 3 minus 4 gives me a negative 1 times the square root of 6. And I can rewrite it without that 1 if I wanted to, and that would be the correct answer as well. And typically what they expect you to have when you are typing in answers on big ideas or in any textbooks, really, they do not expect the 1 because it's understood. So we'd rewrite this as negative square root of 6. Number 2, same idea. Our radicands of 7 are exactly the same. So we're going to combine the coefficients, which is negative 3 and 4, to get a positive 1 square root of 7. And again, because it's 1, we can rewrite it without it. And so our answer would just be the square root of 7. Number 3, we have negative 11 and negative 11. Negative 11 plus negative 11 is negative 22. And we just carry that square root of 21 with it. And so we see our answer here. And it's the same thing for all of them up until number 8. Number 8 is the first problem that we don't have the square root of 3 automatically. I mean, we start off with it, but then we get the square root of 27. So we're going to have to simplify the square root of 27 in order to complete this problem. So since I'm going to rewrite the square root of 27, I'm going to go ahead and rewrite the whole problem and just put parentheses for the radical that I am expecting to simplify. So it's going to say negative 2 square root of 3 plus 3 and then put parentheses, because again, I'm going to take that 27 and put it as the base of my birthday cake. All right, so I'm going to divide this. The prime number 2 does not work, so I'm going to move to 3. That gives me 9, and then that's pretty obvious. I can divide by 3 until I get that 1 on top. 1, 2, 3, 4, 5. There we go. So I have a group of 3 here. Remember, the group of numbers that I circle is allowed to leave the radical. So it would say 3 times the square root of what I don't circle, which is 1, 3. And I'm just going to highlight it just to make sure our grouped ones I'm going to put in yellow, and then I'm going to show where it went. It went outside. And then our piece that we had by ourselves, by itself, is just that lone 3 at the top, and I'll put that in green, and I'll represent it being alone under the radical in our problem. Well, now that I've done that, it's just a matter of PEMDAS. So I look for parentheses. I have parentheses, but I can't really do anything inside of it. I've already simplified it as best as I can. Then I go to exponents. I have no exponents. The next step is multiplication and division, and I actually do have multiplication in this particular case. Anytime you have a number in front of parentheses like this, we have a number 3 in front of the parenthesis right there, that signifies multiplication. So I'll rewrite this as negative 2 times the square root of 3 plus 9, because 3 times 3 is 9, and then just carry that square root of 3 there. Now it's just like problem 1 through 7. I'm going to add my coefficients to get 7 times the square root of 3. And it's the same thing over and over again. So number 9, same idea. And for this one, we have 6 and 24. Now, if I did the factor tree or the birthday cake method for 6, I would get 1, 2, and 1, 3. So I don't actually get any groups. So the square root of 6 is already simplified. So I'm going to leave it as is. I need to focus on the square root of 24. So I'm going to rewrite this. 2 times the square root of 6 minus 2 parenthesis, and I'm going to take that 24 and put it as the base of my birthday cake. So I can divide by 2 to get 12, divide by 2 again to get 6, divide by 2 again to get 3, and then I have my birthday cake candle. There we go. So I'm still looking for a group of 2. I only have one group of 2 here, so that gets to leave. And I did not circle 2 numbers now. So remember, when you're doing this, please make sure that you are multiplying the pieces that you have left over. In this case, I have 3 and 2, so 3 times 2 is 6. So my answer should say 2 times the square root of 6. Again, we go back to PEMDAS. So I can multiply and get 2 times 2, which is 4. Add my like terms to get 2 minus 4, which is a negative 2 times the square root of 6. And as we keep going, it just gets a little bit more and more challenging. It just builds upon itself. So for number 18, we are no longer working with 2 radicals, but we're working with 3. So again, we're going to start off by writing everything with our square roots that we are expecting to reduce as parentheses. So that'll be the square root of 18, square root of 8, and square root of 24. So I'll rewrite it. Negative 3, parenthesis, that's where the square root of 18 reduced is going to go, plus 3, parenthesis, that's for the square root of 8, and then minus the square root of 24. Now, on the other page, I believe it was number 9, we actually did this one already. If we do the square root of 24, we should get 2 times the square root of 6. So when you're doing this, if you do it the first time, you do not have to redo it every single time you see it. You can just use the information that you've already worked out and just enter it into the parenthetical space. So I'm going to only do the birthday cakes for 18 and 8 in this problem. So I'm going to say 18, divide that by 2 to get 9, divide that by 3 to get 3, etc. And I have my group here. So this is going to say 3 times the square root of 2. Same thing again for my base of 8, divided by 2 to get 4, divided by 2 to get 2, and get that 1 on top. And we have a group of 2 here, so that gets to leave 2 times the square root of what's left over, which is 2. Now it's just multiplication and then addition. So negative 3 times 3 is a negative 9 times the square root of 2. 3 times 2 is a positive 6 times the square root of 2. And technically there is a understood 1 here. So negative 1 times 2 is a negative 2, square root of 6. Combine like terms. I only have like terms in the front with that square root of 2. Negative 9 plus 6 gives me negative 3 times the square root of 2. And you just tack on the piece that we did not combine at the end. And this is our answer. The number 19 was one we did in class. I just want to make sure we have it. Again, we only have to do the work for new problems or new radicals. So we've already done 18 and 27. So we're going to rewrite everything with our parentheses because we're going to reduce all of these. Again, we've already done 18 from problem number 18. So that's 3 times the square root of 2. And then 27 was 3 times the square root of 3. And I believe that was from problem number 8 on the previous page. The only work we have to do is for the square root of 12. So we'll do our birthday cake method, get all these numbers situated, and I see that I have a pair of 2s. That leaves, and the 3 stays. Go ahead and multiply everything. And once we multiply everything, we can see that we still have the square root of 3 does have like terms we can add, but that 9 square root of 2 does not. So we're just going to put that at the front, and we'll combine the like terms with our 6's. So we got 9 square root of 2 plus 12, because 6 plus 6 is 12, times the square root of 3. The last one that I want to do is just to show you that you can get some things done before you even get started. So 26, I have 3 square root of 20s in a row. So I'm going to go ahead and combine all of those coefficients, so I only have to really look at 2 of them. If we do this, we get 2 minus 1, which is 1. 1 plus 3 is 4. So we get 4 times the square root of 20 minus 2 times the square root of 45. I'm going to rewrite it where I put parentheses around all of my radicals, and I do the work for the square root of 20 and the square root of 45. So 20 is my base. Divide that by 2 to get 10. Divided by 2 to get 5. I have a group of 2 here, so it should say 2 times the square root of 5. Then the same work for 45. I'll divide by 5 first to get 9. And I can see I have 2 3's from this. Okay, so 3 is going to leave the radical, and 5 was not circled, so it's just going to be the square root of 5 here. Multiply, we get 8 times the square root of 5 at the front, Negative 2 times 3 gives me negative 6 square root of 5. Combine like terms to get 2 square root of 5. And that's it. You just do the same thing over and over again. Remember, if you've already done the work for a radical, don't do it a second time unless you really want that extra practice.